Alright, so yesterday I showed you how you needed to learn to be able to change from one kind of unit to another. To go from, say, millimeters to centimeters. How many of you feel you can do that? You learn that, you know how to do it. Change from millimeters to centimeters. Can you change from decimeters to hectometers? Nope. Okay. It's all the same thing. Head up, please. You're using the same basic skill for every one of these. And today, it's really going to come into play on the assignment. The assignment we're doing today is an in-class assignment. You know that because it's written in blue. Blue we do in class. Red stuff is homework. And if we begin in class and finish it at home, spit out the other thing in your mouth, Tyler. Trash is right over there. Over there. If we begin in class and finish it as homework, it will be underlined. Okay? So this is going to help you in the in-class assignment right now. Some of you are just so afraid of math that you don't even attempt these kinds of assignments today. Oh, it's a math thing, I just can't do it. There's no reason for that. It's super easy math. You just have to believe me. Okay? If I ask you to tell me which is bigger, 4 or 5? 4. 5 is bigger than 4. That's easy. When we compare these two numbers and I ask you which is bigger, well, forget about the labels right now. Which is bigger? Come on, guys.
197.
Which is bigger?
123. 170.
Forget about the labels. Which is bigger?
170.
170 is bigger than 23. Are you still with me? Okay, I'm going to try to make things easy, but if you're just going to be stupid and blurt out the wrong answer, no, I'm not talking about you. I'm saying in general, if you're just going to blurt out the wrong answer to be funny, that doesn't help, okay? What I'm trying to do is take it down to a very basic level. Comparing numbers isn't easy. What makes it complicated is when we have different labels, and then we don't know. Particularly if you don't even have an idea how big a millimeter is, how big a centimeter is. So let's do the metric dance one more time. Ready? Show me milli, centi, deci, meter, decameter, hectometer, kilometer. There you go. Okay, let's try a little bit fast now. Meter, kilometer, millimeter, decimeter, centimeter. Okay. You want to learn the steps again. Play along then. Meter. Decimeter is the width of this room. Decameter is the width of this room. Okay. Decameter. Hectometer is all the way to the back fence. Kilometer, you got to go all the way to Saguaro. So when I say each of those, you picture it. And sometimes it's easy to picture. 23 centimeters. Can you show me with your hands how big that is? No, with your hands. 23 of those. How big would it be? Would it be this big? This big? How big? Okay? Well, Toya's about the only one that looks like she's in the ballpark right now, and it looks like Zach's got it too. Good. Okay? About this big. How do we know? Because a regular ruler is about how long? Well, how many centimeters? 30. So that's 30. 23 would be like that. So good. All right. So some of you can picture it, some of you can't. When you get into bigger numbers, like 170 of something, it's hard to picture. It's kind of like when you go to the store and they have that little contest. Guess how many jelly beans are in the jar? You know what I'm talking about? Sometimes there are contests. You have to guess the number of jelly beans. And it's really hard to do just by looking at the jar. It's really hard sometimes to picture 170 of these little tiny guys, because they're small. So that's where it's very useful to change it into something that you can picture. Plus, for this particular activity, I'm asking you to tell me which one is bigger. So if you make them in the same units, the answer is quick and obvious. Which one's bigger? Okay? And you did math in your head. All that stuff you did with the little jumps yesterday, she does in her head. And you should be able to do that by the time we're done today as well. Let me just remind you real quick how this is done. Here's my number line up here again. King Henry died Monday drinking chocolate milk. Monday would be where the meters would go. Because it's not just meters. What else could go with? What else do we use the metric system with? Not just meters, but grams and meters. In fact, on our next class, we're going to do just that. We're going to get into grams. And you'll have kilograms, and you'll have milligrams, and so forth. Okay? So it's not just meters. That's why it says base in parentheses. Good question. Okay? So just like before, we're going to use this line. Now I could change this one into millimeters, or I could change this one into centimeters. I like to change the bigger one into the smaller one, simply because it's usually easier. I don't have to put in those extra zeros. I end up with numbers that are easier to compare. I can't picture 170 of those. So I'm going to change the millimeters, into centimeters, so that they agree. That's going to require one jump to the left. This is what you did repeatedly for the homework. Okay? I know the decimal is right here. One jump to the left makes that 17 centimeters, which is bigger. 23. So, Latoya was right and she did it in her head. Now that's easy, but when I give you a number like, let's say, 34 hectometers. Can you tell me how many meters that is? Real quick, 34 hectometers. How many meters? 3,400. Excellent. And if you're wondering how he was able to do that so quickly, just picture it. 34 hectometers. Hectos here. I wanted him to go to meters here. That's 2 steps away. You simply add 2 zeros to these. 3,400. Or you could say you move the decimal 2 places. Same thing. Let's do a few more examples, make sure you have this down. Okay, this next one, 2 hectometers or 500 decimeters. Which one do we want to change? Change the decimeters to hectometers. So I'm starting here and I'm going here. That's going to require how many jumps? 4? 2? 3. We can't count any longer, guys? Look. 1, 2, 3. Here's my decimal. I'm going to move it 1, 2, 3 places. Giving me what? 0.5 hectometers. Now, which one's bigger? 2. Okay. No, you could change this one. Let's just do that as an example. I want to go from hectometers to decimeters. That's going to require 1, 2, 3 jumps to the right. If I do that, 1, 2, 3 jumps means I have to put in 3 zeros. So now I get 2,000 decimeters, which is bigger. 2,000 decimeters or 500? 2,000. No. Not true. Maybe so far, but not always. Okay? You do understand that 2,000 decimeters is the same as 2 hectometers. It's the same exact measurement. Same distance. Just a different label. Okay? Understand? No? Yes? Maybe? Not sure if you're getting this. Alright. I want to just pick on somebody there. Chevy. Since you're in the back. I think I'll be in the back. Let's put this one up. So, Chevy, which one do we want to change? Doesn't matter. There's not a wrong answer. You want to change 1.2? Okay. Makes it easier, but that's okay. So she wants to change the kilometers into millimeters. It's just usually easier. You have to do fewer zeros and stuff when you change the big one to the little one. But you can do it this way. So we're starting here and we're going where, Shelly? Millimeters. That's going to require how many jumps? And then on opposite ends, it's always going to be 6 jumps. Okay? When you've done this enough, you can just picture it in your head. Oh, that's 2 jumps away. That's 4 jumps away. So that's 6 jumps away to the right. You're right. So I'm going to have to take this decimal and do 1, 2, 3, 4, 5, 6 jumps away. That's going to require me to add in some zeros, which makes my answer what? Got it? No, the point's gone way down here at the end now. So it's not 1 point in the game. It's 1,200,000 millimeters. 1,200,000 millimeters. So now, which is bigger? This one. Okay? I probably would have done it the other way around, but it works out the same. I would have changed this to kilometers, and 1,500,000 millimeters is how many kilometers? 1 point what? 1.5 kilometers. And it's still bigger. So you see, it's not always with the bigger ones necessarily, the bigger numbers necessarily the answer. Okay, so here, which one do we want to change first? Centimeters? Again, doesn't matter, but I'll do this. So from the center, I want to go to deca. D-A, deca. How many jumps? 2. 1, 2. We still can't count the little lines up here, can we? 3. 3 jumps to the left. There's my decimal. 1, 2, 3 jumps to the left becomes 4.3 decameters, which is bigger. 4.3. Okay. All right. So you're going to use this in class assignment I'm going to give you now. I'm going to walk you through a few of these that people get confused on. So when you get this, get your name, date, and period on it. You guys dating or something? Okay. Get your name, date, and period on the top. This is going to involve doing exactly what I showed up here. Making an estimation or putting a label on the answer. For instance, the first one there, let's do that together. The width of a postage stamp. They've already done the measurement. All you have to do is put a label on the answer. Is it 24 of these millimeters? Is it 24 of these? 24 of these? 24 of these? Right off the bat, some of them are going to be obvious that they're not the right answer. Okay? If you know the metric dance. How big is a postage stamp? Show me with your hand. That's a pretty big stamp. Maybe like this, maybe a little bigger, something like that. Okay? So that's the size of a postage stamp. And it's 24 something. You go through the list. Right off the bat, you know it isn't going to be 24 of those. That would be unreasonable. Okay? Would it be 24 of these? Decimeters. Would it be 24 of those? 24 of those, guys, is that big. That's a big postage stamp. The thickness of your piece. That's a centimeter. That is a centimeter.
No, I thought like that's centimeters.
Yeah, either way, this is a centimeter. 24 of those would be that big. That's a big postage. Okay? 24 of those would be how big? Exactly. Okay? Because 24 millimeters is how many centimeters?
2.4.
You got it. So the answer then for number 1, what you're going to write down would be
Millimeters.
You need to abbreviate, okay? We're looking for MM, CN, KN, DN for all these. I should see the abbreviation. Do not write just Miller, that would be wrong. Now there's a few others here that people probably don't know. Maybe you've never cooked before, so number 5 throws you off. Look at number 5. You can answer these as we go through it. Length of a cookie sheet. How big is a cookie sheet? About that big. Okay?
What? Are you serious?
Huh? What are you surprised at? It's about that big. Okay, it could be a little bit longer, a little bit shorter, but it's about that big. See, here's the thing that's easy with the metric system. Yeah, I have hands a little long. The thing that's easy about a metric system, is if it's not meters and it's hectometers, how much bigger are hectometers than meters? 100 times bigger. How much bigger are decameters than meters? 10 times bigger. So, if it isn't one, the next one is 10 times bigger or 10 times smaller. For instance, on that one, cookie sheet, 35 of those. Think about it. The other option, the next one up, is 35 of those. Okay, that's definitely out. 35 of those. Okay, so one of them's clearly going to be the right one. The other ones are going to be way too big or way too small. Next one, number 7, width of a textbook. I don't mean the thickness, guys. I mean, your textbook is like this, so that would be the width of the textbook, something like that. Number 8, distance between city blocks. Consider it this way. Here's your street. Here's the street behind you. The next row of houses. How far apart are those two streets? Okay? A lot of people think that number is a lot bigger than it should be. So you got 200 of these, 200 of from there to there. Can you please stop it with the desk? Can you be outside? Yeah. Okay. In the next column, number 9, height of a one-story building. This is a one-story building. Now, granted, it's going to be a bit taller from the outside. You're looking at it from the inside. Over there by the door, you can see a couple of meter sticks already lined up. That might give you a clue. Width of a picture frame, something like that. Width of the light switch plate. Okay. We're talking about something about this big. Okay, light switch plate. We back up to width of a street. I don't mean speed limit. Okay, I mean like your street. How far is it across the street? The length of the street, let's say just cross it. Number 14, a pearl. How big around is a pearl? Show me. You show me. It's like that big, right? Some people show me like this for a pearl. Let's see, okay, something like that. Okay? Now, on the bottom part, what you're doing is you're selecting from the 3 choices which one seems most reasonable. And you got to be careful because at first glance you might think it's the wrong answer, okay? Number 1, the height of a table. 1.5 meters sounds like, oh, that could be about right. Okay? This is different than the top part. The next one's not necessarily going to be 10 times bigger or smaller. So I think 1.5 meters. That I can picture. Here's a meter. 1.5 would be something like this. That's a pretty tall table. Let's look at the next one. The next one is 84 centimeters. 84 pinkies high. You can't picture that. So what I'm going to do is turn that into something that I can picture. Maybe decimeters, hands. How many hands would that be? 8.4. I can kind of picture that. Or if I turn it into meters, how many meters would that be? 0.84, which is about that tall. Okay. Small table. It's a height of any table. When you go to sit down, your desk is a perfect example of a table. So it's a typical height of a table. Okay? Well, but let's look at the third one just before we conclude that that one's the right answer. The third one, it says, or C, letter C says 356 millimeters. I definitely can't picture that, so I'm going to turn that into centimeters. How many centimeters is that? 35.6. How many hands is that? 3.56. That would be a table about this tall. Doesn't sound right. So the obvious one should be, okay. So go ahead and work through these. You are not to be talking. This is an individual. All right, I'd like you to pack up so you're ready to go. But I'm going to cover some more information. I want you to get this. That's why I'm asking you to pack up, so you won't be distracted with stuff around you. Okay, guys, we're about 5 minutes behind where we need to be, so if you'll please be quiet, I can get started here. You're going to take notes on this next class. And it's on the difference between mass and weight. But before I get into that, let me just share with you real quick. Some of you might have heard that I have a special talent.
Wait, are you going to read mine, right?
Okay. Thank you. By the way, I'm getting them turned in here with no grades on. It's supposed to be the number correct out of 31. You did Toya's paper. You want to put the number correct?
Yes, I have.
So, among my talents, this is a little secret, just pass it over. Among my talents is my little secret that I'll just share with you. I'm an inventor. I've invented a number of different little things, some that I have done almost nothing with, and someone else has made money off of my idea. But one of the ideas, if you'll get your head up please, that I'd like to share with you now, one of my favorite inventions, and I think it'll be the most valuable invention of anything that I've come up with, is my own weight loss plan. You know, all the weight loss plans shown on TV, that they show on TV require you to go on a special diet, exercise for a long time, and then they can only say that you'll lose 20 pounds after a certain amount of time, and I just don't think that's acceptable. I think you ought to be able to lose as much weight as you want, and you should be able to lose it instantly, okay? No delay whatsoever. And that's what you can do with my plan. Do you believe me?
Yes, sir. No, I don't.
I will demonstrate for you right now. I will lose all the weight that I want, and I'll lose it
Oh, wait.
just like that, okay? Give me a drum roll, please. 1, 2, 3. There, I lost all the weight. Head up.
What?
And just like in most diets, you lose all the weight, and then what happens?
You gain it all back.
You gain it all back. As I was falling, I was weightless. I weighed 0 when I hit the ground. When I hit the ground, I gained all the weight back. Did I change what my body was made up of? No. Same material. Did I actually have fat come off and fall off my body? No. Did I change my body shape? No. All I did is change my weight, and that's what we're going to be investigating more on Monday, because we're getting in now to measuring weight and mass, and they're not the same thing. Okay, we're still using the metric system, but now instead of millimeters, we're going to look at grams. Instead of kilometers, kilograms. Got it? And this device right here measures what? Weight or mass? This measures weight. It shows the effect of what? What's causing that? What's causing that needle to go up? My weight and what other thing? Gravity. It's the effect of gravity on my body. And you should know that if you were to duct tape this to my feet and I were to jump off the table, what would it read when I'm in the air? 0. And in fact, I haven't lost anything. You might argue, well, that's not a weight loss plan. You didn't lose anything. You still have everything. Because you're not thinking about weight. You're thinking about the stuff that's in my body. And that stuff is the mass. You have mass. Everything has mass. But depending on what you're doing and where you are, that mass is affected differently by gravity. It may make you weigh more. It may make you weigh less. In fact, if I landed on the ground with that scale duct taped to my feet, it would actually give me a higher reading than my real weight when I hit the ground. I didn't gain weight, okay? And I'd probably break it. But I know the bell's going to ring. I want to show this to you real quick. It'll just take a few seconds. This just demonstrates that I was in fact weightless. But some people don't believe it. The cup and the water both have mass, and they both have weight. And because of that, they're going to want to be pulled down to the earth. You all agree that if I release this, it will fall, right?
Yeah.
And if I take my finger off of the hole, what will happen to the water in the cup?
Squirt on me.
It will squirt out the hole. No big shock. But if this is in fact weightless when I drop it, not only is the water weightless, but so is the cup. What will happen when I let go? The water will stay in the cup the whole way down because it was weightless. See you Monday.